Hello students, in today's class we are going to see the problems on miscellaneous exercise, and most of the problems in the miscellaneous exercise is based on permutations and combinations. Hope you remember the chapter permutations and combinations. What we learnt under permutations and combinations, the number of chances for the particular event to occur only, right? Permutations, in how many ways the particular event, we will say event and probability. In permutations and combinations, we will say in how many ways the particular thing can happen. For example, if we want to arrange a 5-digit number, if we have 5 digits and if we want to form 4-digit number, in how many ways a 4-digit number can be formed using those 5 digits. For example, say 0, 1, 2, 3, 4, 5. Using these 5 digits, how many 4-digit number can be formed? So these kind of things we have solved using permutations and combinations. When the order is not important, we will go for combinations, right? Now probability and permutation and combinations have a close relationship, because in the probability we are going to see how many chances are there for the particular event to occur out of the total number of events. Yes, if for example take the same example what I quoted before, how many 4-digit number can be formed using the given 5 digits? That is our sample space. Okay, out of that sample space, our event is getting a number divisible by 2 is my event. So out of all the 4-digit number, how many chances are there while picking a number? It should be a number divisible by 2. That is what my event, right? Finding how many 4-digit numbers are there using the given 5-digit itself can be found using combination. So using combination we can get how many numbers are there. Then we have to go for probability. Probability is number of favorable outcomes divided by total number of outcomes. That number of outcomes and number of favorable outcomes can be found using combinations for certain problems. That kind of problems only we are going to see under miscellaneous exercise, right? If we solve problems, you will get a better clarity. Let us see the first example. A box contains 10 red marbles, 20 blue marbles and 30 green marbles, and 5 marbles are drawn from the box. What is the probability that all will be blue and at least one will be green? Alright. Now first we are going to choose 5 marbles out of these 10, 20 and 30 green marbles. Right. Now what is the possibility? How many ways these 5 marbles can be drawn out of these? The total number of marbles here is 30 plus 20 plus 10. So total number of marbles is 60. So out of 60 marbles, 5 marbles should be drawn. So in how many ways these 5 marbles can be drawn? In 60C5 ways. Right? 60C5 ways. See, total number of ways drawing 5 marbles out of 60 marbles is 60C5. In 60C5 combinations, these 5 marbles can be drawn. This is total number of outcomes. This is our sample space. Now our question is, what is the probability that all 5 will be blue? So what is the probability formula? Number of favorable outcomes divided by total number of outcomes. So what is number of favorable outcomes here? We need to get all the 5 marbles to be blue colored marbles. So how many ways are there for these 5 marbles to be blue colored? The total number of blue marbles is 20. Therefore 20C5 divided by total number of outcomes is 60C5. Okay, so if you have a smaller numbers, you can simplify and give your answer. If it's of bigger number, you can leave it as such. So you have to solve this, right? Probability of all will be blue is 20C5 divided by 60C5. Hope you got it. The next question is, at least one will be green. So what is the probability of getting at least one will be green? At least one will be green can be read like 1 minus probability of none of them is green. Yes, we are going to go with the complementary event now. See, probability of at least one will be green is equal to 1 minus probability of no marble is green. Instead of doing this is easier. So you can do in this way. So what is the probability of getting no marble green? So we have to find in how many ways those 5 marbles can be drawn in which none of the marble is green. So for that you have to check out the question. In this 20 blue marbles and 10 red marbles are there. 30 are green marbles. So 20 plus 10, 30. Out of this 30, 5 should be chosen. Then only those 5 cannot be a green marble, right? So in how many ways it can happen? 30 C5. So 30 C5 divided by total number of ways is 60 C5, right? So the answer is 1 minus 30 C5 divided by 60 C5. You have to simplify this, right? Hope you got it. Let us move on to the second question. Now see the second question, it's also of the same kind. 4 cards are drawn from a well shuffled pack of 52 cards. What is the probability of obtaining 3 diamonds and 1 spade? So out of these 4 cards, 3 should be diamond and 1 should be spade. These are all not 2 different events. If it is of 2 different events, when we have and, we can use the formula. What is that formula? Probability of A union B is equal to P of A plus P of B minus P of A intersection B. If they are of 2 different events, but they are not 2 different events, only one event. The event is to pick 4 cards from a deck of 52 cards. But the event here is, the experiment is getting 4 cards out of 52 cards. The event is 3 diamond and 1 spade. Those 4 cards should be 3 diamond and 1 spade, right? The same way, the total number of ways of getting 4 cards out of 52 cards is 52C4, right? 52C4. Number of ways of drawing 3 diamond and 1 spade is 13C3 into 13C1. Why this 13? Because there are 13 diamond cards and 13 spade cards. So out of these 13, 3 should be diamond. Out of these 13, 1 should be spade. So 13C3 into 13C1 is the number of favorable outcome. So probability is this divided by this. That's it. Okay. Let us move on to the third question. A die has 2 faces each with number 1, 3 faces each with number 2 and 1 face with number 3. If die is rolled once, determine probability of getting 2, probability of 1 or 3, probability of not 3. So normally a die will have 6 faces and 6 faces will be numbered like 1 to 6. But instead here they have given you 2 faces numbered with 1, 3 faces numbered with 2 and 1 face numbered with 3. Now you have to find the probability of getting 2. Hope you can do by yourself. 3 faces have 2 out of 6. What is 1 or 3? 1 or 3 means 1 union 3. Getting 1 or getting 3. It is like 2 events. So probability of 1 or 3 can be written as probability of 1 plus probability of 3 minus probability of 1 intersection 3. But getting 1 and 3 are mutually exclusive events, right? They do not have any intersection. Therefore, probability of 1 or 3 is probability of 1 plus probability of 3. Not 3 means complement. You should not get 3, which means you should get 1 or 2. Okay, or else you can do 1 minus probability of getting 3. Okay, I am leaving this problem to you. Let us move on to the next question. In a certain lottery, 10,000 tickets are sold and 10 equal prizes are awarded. Out of 10,000 tickets, 10 tickets are awarded with prize. What is the probability of getting a prize if you buy 1 ticket, 2 tickets or 10 tickets? Okay, so total number of tickets is 10,000. Number of prizes awarded is 10. Okay, now if we buy 1 ticket, if we buy only 1 ticket, then probability of getting a prize. What is the probability of getting a prize? Probability of not getting a prize. I'm sorry. I'm sorry, question itself not getting a prize only. Probability of not getting a prize if you buy one ticket. So probability of not getting a prize, number of favorable outcomes divided by total number of outcomes. That is what our formula. So number of favorable outcomes means number of ways in which you cannot get prize. You cannot get a prize. So how many ways are there? Out of 10,000 tickets, 10 tickets been awarded prizes. So 10,000 minus 10 is 9,990. So there are 9,990 possibilities for not getting a prize. So that is what number of favorable outcomes. Since we have taken only one ticket, divided by total number of tickets is 10,000. Right? So if you simplify, we will get the answer. So what will happen if we buy 10 tickets? If we buy 10 tickets, then the probability of not getting a prize is going to be, out of this 9,990, we are going to take 10 tickets. So how many ways we can take those 10 tickets? 9,990 C10. Why this 9,990? Because this 10 we have subtracted from this 10,000. Why? Because 10 tickets been awarded prizes. So we are concentrating on not getting prize. So only 9,990 tickets been not awarded prizes. So out of those 9,990, we are going to take 10 tickets. Okay. Those 10 tickets can be taken in these many ways. Divided by total number of outcomes is going to be 10,000 C10. Okay. Hope you got it. Why we didn't use combination here? We have used combination, but it's not C, because 9,990 C1. Out of those, we are going to choose only one. So it is going to be 9,990 only. Similarly, the denominator. Since we are taking 10 tickets, if it is more than one, we have to go for combinations only. 10 tickets, therefore it is 9,990 C10 divided by 10,000 C10. If it is going to be 2 tickets, the same way. Okay, 9,990 C2 divided by 10,000 C2. Hope you understood. See the fifth question. Out of 100 students, 2 sections of 40 and 60 are formed. If you and your friend are among the 100 students, what is the probability that you both enter the same section? You both enter the different sections. Nice question, right? So there are 100 students and 2 sections are there, 40 and 60. Now we have to find out what is the probability that you both enter the same section or you both enter the different section. First, let us find what is the number of ways of selecting 2 students out of 100 students, which is nothing but 100 C2. Right? Now 2 of us will enter the same section if both are among those 40 students or among those 60 students. Right? Then only they two will enter the same section. Either they should belong to the first 40 or they should belong to the next 60 students. So if they belong to the 40 students, then the number of ways those 2 students can be selected is 40 C2. Plus, if they belong to the next 60 students, they can be written as 60 C2. So the probability of entering the same section is going to be number of favorable outcomes divided by total number of outcomes. Yes? Hope you understood the difference between this question and the second question. In the second question, we have multiplied. In the second question, we have multiplied. But in the fifth question, we have added. Why? Because as I told you in the second question, it is not like 2 different events. A single event is splitted into 2. Those 4 cards, out of those 4 cards, 3 should be diamond and 1 should be spade. So it is like a single event. So the combination can happen. Okay, that's why we have multiplied. But here it is like 2 different events. See, if they belong to 40 students, the chances is 40 C2. If they belong to 60 students, 60 C2 chances are there. They are independent. So we are adding. Okay, they are independent, that's why we are adding. So the probability is number of favorable outcomes divided by total number of outcomes. The second question is, find the probability that they enter different sections, which means it's complement of this 1 minus probability of same section. We don't want to undergo the same procedure again, right? So we can write 1 minus probability of they enter the same section, the answer which we got in the first subdivision, right? When you get a complicated combinations, you can leave the answer with combinations, or else you can simplify and give your answer according to the marks which has been allotted to the question. Yes, let us move on to the sixth question now. See the sixth question. 3 letters are dictated to 3 persons and an envelope is addressed to each of them. The letters are inserted into the envelopes at random so that each envelope contains exactly 1 letter. Find the probability that at least 1 letter is in its proper envelope. So there are 3 letters and 3 envelopes. 3 letters are dictated to 3 persons, right? And an envelope is addressed to each of them. So we have to find out whether at least 1 letter is being inserted in the proper envelope. Now how to do this? Let the letters be named as L1, L2, L3 and their corresponding envelopes as E1, E2, E3. Then how many ways these 3 letters can be inserted in the 3 envelopes? 6 ways, right? How? See, I have written all the possibilities. This you have to slowly think in order and write. Okay. So first I have written L1, E1, L2, E2, L3, E3. Everything is placed correctly. Then I have fixed L1, E1. Then I changed L2, E3 and L3, E2. Okay. Then next I have fixed L2, E2 and I have written L1, E3 and L3, E1. These two I have changed. Then I have fixed L3, E3. Then I have changed these two. Okay. Then next I have shuffled everything. L1, E2, L2, E3, L3, E1. Similarly, I have shuffled again. There is another way of shuffling this. One is 2, 3, 1. Another one is 3, 1, 2. Right. That's it. These are the only possibilities of inserting 3 letters in 3 envelopes. Okay. Now this is the sample space. Now the question is, what is the probability at least 1 letter is inserted in a proper envelope? See, this will come. 1 letter is inserted in a proper envelope. If you choose the first option, at least 1 only asked, but here all the 3 are inserted in the correct envelope. So minimum 1. And here also L1, E1. Then here L2, E2. Here L3, E3. And here all the 3 are different. Here also all the 3 are different. Therefore, there are 4 ways in which at least 1 letter is inserted in a proper envelope. So, probability of the event is 4 divided by 6, which is nothing but 2 divided by 3. Right? Let us see the 7th question. A and B are 2 events such that P of A, P of B, A intersection B, all the values are directly given. They asked you to find A union B, A dash intersection B dash, A intersection B dash, B intersection A dash. A union B, you can do it directly. P of A plus P of B minus P of A intersection B. What is probability of A dash intersection B dash? It can be written as A union B the whole dash. Right? A union B you can do De Morgan's law. I have told you already. This can be written as A union B the whole dash. When it comes A union B the whole dash, just nothing but 1 minus probability of A union B. A union B already you have found. So you can subtract. Again, how will you write this? This also I have taught you already. Probability of A intersection B dash. What is A intersection B dash? A intersection B dash means choosing A and not B. Probability of the event A and not B. Right? Choosing A and not B. So this part alone. So how will you write this part? This part is n of A minus this intersection. A means this full part. From this full part, we have to subtract the intersection. This is our intersection area. So from full part, if we subtract the intersection, we will get A intersection B dash. A intersection B dash is nothing but this region. Alright. Since these two are independent events, probability of A intersection B dash is nothing but probability of A minus probability of A intersection B. If you substitute, you can find the answer. Similarly, the next subdivision, probability of B intersection A dash also can be written in the same way. Probability of B intersection A dash. Right? Hope you can do this. Let us move on to the next question. From the employees of a company, 5 persons are selected to represent them in the managing committee of the company. Particulars of 5 persons are as follows. A person is selected at random from this group to act as a spokesperson. What is the probability that the spokesperson will be either male or over 35 years? See, he should be a male or over 35 years. These two are independent, two different events. Okay. The chosen person must be a male or the person should be over 35 years. So these are two different events. So here we can go with the axiom of probability. Okay. First, let us find what is the probability of getting a male and what is the probability of getting a person who is over 35 years. Then we can apply in the formula. So what is the probability of getting a male person here? Out of 5, how many male are there? 3 male are there. So 3 divided by 5 is the probability of getting a male person. Now what is the probability of getting a person who is over 35? Over 35 only 2, right? So 2 divided by 5 is over 35. So do we have any intersection for these two events? Yes, we have, because there is a male whose age is over 35. So there is one intersection, right? So 1 divided by 5 is the intersection. After finding all these, substitute in the formula. That's it. See, 3 by 5, 2 by 5 and 1 by 5, then substitute in the formula. Either A or F means union, right? Union means probability of the first event plus probability of the second event minus probability of the intersection. That's it. Okay, let us move on to the next question now. 9th question. If 4-digit numbers greater than 5000 are randomly formed from the digits 0, 1, 3, 5 and 7, what is the probability of forming a number divisible by 5 when the digits are repeated and the repetition of digits is not allowed? Yes. So how can we do this? First, we have to check out how many 4-digit number greater than 5000 can be formed using these many digits. Then we have to, that is what our sample space. Then we have to check how many numbers greater than 5000 can be formed which is divisible by 5 when the digits are repeated. Then that divided by the total number of numbers will give you the probability answer for the first one. Then we have to check what is the probability when the digits are not repeated. So 2 ways we have to find out. Let us see how to solve this problem now. See, the total number of, there are 4 places, 1000, 100, tens and ones. We have to fill these 4 places using these 5 digits. Okay. Total number of 4-digit number greater than 5000. When it comes to greater than 5000, clearly 1000th place can be occupied by either 5 or 7. Right? 1000th place can be occupied by 5 or 7. So 1000th place is been fixed. So in how many ways we can select a digit for the 1000th place? 2C1 ways. Out of these 2 digits only we have to choose one. Therefore it is 2C1. Right? Since the repetition is allowed, in the 100th place we can choose any one among these 5 digits. We are not bothered about 0 also. 0 can also appear in any one of these places. Right? So 5C1 possibilities are there for the 100th place. The 10th place also 5C1. For 1's place also 5C1. Out of these 5 digits we are going to choose one because the repetition is allowed. Okay. So 2C1 into 5C1 into 5C1 into 5C1. Why are we subtracting this 1 from here? Because 5000, we are going to remove 5000 because we are talking about the number greater than 5000. Since the repetition is allowed, there is possibility of getting a number 5000 here when 5 appears in the 1000th place and 0 is repeated for the remaining 3. So we have to omit that number because we are worried about greater than 5000, not greater than or equal to 5000. So we are removing that 1 from here. Okay, 2C1 is 2 into 5 into 5 into 5 minus 1, which is 249. So this is our sample space, total number of outcomes. Now our event is getting a number greater than 5 which is divisible by 5. Right? So, and the digits can repeat. So again 4 places are there. First, when we go for the 1000th place, it should be a number greater than 5000. So out of these two digits, 5 or 7 is fixed there. So out of these two only they have to choose. So how many ways are there? This denotes number of ways. Okay. How many ways are there? 2 ways. 2C1. Out of these two digits only they can choose one digit. And since it should be divisible by 5, the ones place is also fixed. What is it? Either it can be 0 or 5. If it is of any other digit, it cannot be divisible by 5. Again, the ones place is fixed among these two digits. Therefore, again only 2 ways. For this hundreds and tens place, we have 5 chances. Out of these 5 ways, 5 digits, they can choose any one. Right? So 2C1 into 5C1 into 5C1 into 2. Again, we are subtracting 1 because 5000 can also appear here because last digit is 0, it is divisible by 5. But we have to omit that because we are talking about a number greater than 5000. Right? Greater than 5000. Okay. So we are subtracting 1. So our answer is 99 and hence the answer is 99 divided by 249. Hope you got it. Now next let us see when the digits are not repeated how to solve this. When repetition is not allowed, total number of 4-digit numbers greater than 5000 is going to be again the 4-digit, right? Since it is greater than 5000, 1000th place can be 5 or 7, right? So only two ways are there. Only 2 ways are there. So when one number is being fixed here, out of those 5 digits, 0, 1, 3, 5, 7, out of these 5 digits, we have fixed one digit in the 1000th place. So remaining how many chances are there for the 100th place? 4. Again, one digit is being fixed in the 100th place, so we have 3 chances for the 10th place. Again, 2 chances. These kind of problem we have done in our permutation and combination chapter. Hope you recall. Right? So 2 into 4 into 3 into 2. 2C1 into 4C1 into 3C1 into 2C1, which is nothing but 48. Here we didn't subtract 5000 because there is no possibility of getting the number 5000 because the repetition of the digits is not allowed. So we cannot get repeatedly 0 there. So 5000 cannot appear here. Okay. Again here 2 cases may appear. One is when 1000th place takes the digit 5. How many numbers are divisible by 5? When the 1000th place takes 7, how many numbers are divisible by 5? We have to find 2 different and then we have to add, because again this is like 2 different events. They do not have any intersection because the digits is not repeated. Yes. So when the 1000th place is being fixed with 5, when the 1000th place is fixed as 5. So how many chances are there? Only 1. It can be 5. Right? Then ones place should be 0 or 5 for the number to be divisible by 5. But out of these two, 5 is been already taken for 1000th place. So how many chances are there for the ones place? Only 1 chance. It can be only 0. Okay. So how many now? 1000th place is being fixed, ones place is being fixed. So out of 5, 2 numbers are removed. Since the repetition is not allowed, we cannot repeat. Once the number is being fixed, we cannot repeat. So we fixed the 1000th and the ones place. So remaining 3 numbers are there. Out of 3 numbers, we can choose any one number for hundreds place. Therefore 3 chances. And again one number is being fixed. There is only 2 chances for the 10th place. Okay. So 1 into 3 into 2 into 1, which is nothing but 6. 3 2s are 6. 6 chances are there to get a 4-digit number greater than 5000, which is divisible by 5 when the 1000th place is being fixed as 5. So what will happen if the 1000th place is fixed as 7? Again in the 1000th place we have only 1 chance. Right? But in the ones place it can be 0 or 5. It can take up any one digit, 0 or 5. So it has two options now. It has two options, but when we check out, here one digit is locked, here one digit is locked. So totally 3 more digits are there. Out of 3 more digits, tens place can take up any one digit, or hundreds place can take up any one digit. So the other place can take up only 2. Hope you understood, right? So we have 5 digits. Out of those 5 digits, we have fixed 1000th place and we have fixed ones place. So left out is 3 digit. Out of 3 digits, hundreds place can take up any one digit. Again, hundreds place is locked. Now tens place can take up any one among those two. Right? It is not, it doesn't matter whether it is going to be hundreds or tens. You can interchange and write 3 into 2 or 2 into 3. Yes, don't get confused with this 2 and this 3. Here we have written 2 charges, so 1 plus 2, 3. So remaining 2 digit only, don't get confused. This 2 is number of ways. Number of ways. This is talking about number of ways. It has number of 2 ways of locking a digit in the ones place. Even it has 10 ways, we are going to write only one digit under ones place, no? Right? Even if it has 101 ways of fixing up the digit for the ones place, we are going to write only one digit there. So when one digit is fixed there, how many digits are left out? With that only we are going to fix the remaining places. Okay? Understand it and then proceed with the problem. Now if you multiply all these, 2 3s are 6, 6 2s are 12. So there are 12 numbers which are 4-digit number greater than 5000 divisible by 5 when it takes up the 1000th place as 7. Now we have to add these two. 6 plus 12 is 18. So this is our favorable outcome. So the probability is favorable outcome divided by total number of outcomes. So it is 18 divided by 48. Right? Understand and do it properly. Okay. The last question, the number lock of a suitcase has 4 wheels, each labeled with 10 digits, 0 to 9. The lock opens with the sequence of 4 digits with no repeats. No repeats. What is the probability of a person getting the right sequence to open the suitcase? Right? So there are, first we have to find the total number of ways of selecting 4 different digits, because the repetition is not allowed. 4 different digits out of 10 digits. 10 digits are 0 to 9. So out of these 10 digits, we have to choose 4 digits. So how many ways? 10Z4. Right? Now each combination can be arranged in how many ways? Each combination can be arranged in 4 factorial ways. These 4 digits can be arranged in 4 factorial ways. For example, if I am going to choose 1, 2, 3 and 4, this can be again arranged in 2, 3, 1, 4 or 3, 2, 1, 4. Likewise, I can arrange it in 4 factorial ways. Right? So, the number of digits with no repetition is 10C4 into 4 factorial. Right? So what is 10C4? 10 factorial divided by, this kind of problems also we have done under permutations and combinations. This is merely like a revision for your permutation and combination. So 4 factorial into 10C4 is 10 factorial into 4 factorial into 6 factorial, because n factorial divided by r factorial 10 minus r factorial. Right? So if you simplify, we got 5040. 5040 is the number of ways of selecting 4 digits out of these 10 digits without any repetition. Right? Now our question is to get the selected number. Those 4 numbers should be the correct sequence. So what is the correct, how many ways we can get a correct sequence? Only 1, because the 4 digit is being fixed. Right? The correct sequence is being fixed. How many chances are there to get the correct, the number of favorable outcome? I am talking about the numerator. The denominator we found. Numerator is number of favorable outcomes. How many favorable outcomes we have? Only 1. That 4 digit, that sequence is being fixed. Only if it appears that 4 digit in that sequence, it is correct. Okay, it will match. right? So the number of favorable outcomes is 1. So the required probability is number of favorable outcome divided by total number of outcomes, which is 1 by 5040. Yes, hope you understood. So with this, let us wind up today's class. I want you to do miscellaneous exercise 1 to 10 questions as a homework. Even though I have explained all the questions, I want you to redo, because first time when you see it may look complicated because it is completely based on permutation and combination chapter. So understand it and do it properly. Okay, if you have doubts, you can ask me. Thank you, students.